I hope we are doing very well. Okay, and we've had a good breakfast. And we are energized. Right. Remember, it's the very first contest in the round of the semi-finals for the 2025 Junior Science and Maths Quiz. This is the very first one. So the expectations are high, and I'm sure the stakes are also extremely high. So the 2025 Junior Science and Maths Quiz is proudly organized by the Kwame Nkrumah University of Science and Technology and supported by the College of Science and the College of Engineering. We would really want to appreciate all our sponsors for coming on board to support us in diverse ways. Indeed, we want to say we are very grateful to every single one of them. And so the 2025 Junior Science and Maths Quiz competition is proudly sponsored by the KNUST e-Learning Center. For all our media and video coverages, the beautiful pictures you've been seeing online, we say we are truly grateful to them. At the KNUST Institute of Distance Learning, we want to thank them for providing us with amazing venues. Indeed, we combed through the nooks and crannies of this nation, and they provided us with very beautiful venues. We say thank you very much to them. Dex Technologies, at Dex Technologies, we say practical science is now practical. We want to thank them for always making our technology challenge a reality, and I'm positive today's challenge will definitely be an exciting one. And indeed, it's also going to be hands-on. Ghana Grid Company Limited, Gridco, they provide reliable electricity grid for development. Thank you very much. MTN Stakeholders Management. At MTN, we say everywhere you go. Nestle Ghana Limited, good food, good life. Diopta Eye Consult, they say that your vision matters to them. And vsEMMANUEL Cakes and Catering Services. Finger-licking dishes and punctualities is indeed their hallmark. And of course, to our media partner, Kesben TV, we want to thank them for joining, collaborating, partnering with us to ensure that our broadcast reaches everywhere in Ghana and even beyond. We say we appreciate them for this collaboration. We also want to appreciate the heads of the various schools participating in the 2025 Junior Science and Maths Quiz. We say thank you for registering your schools and importantly, allowing your schools to join in this year's competition. Teachers, amazing teachers, thank you for training these young brains so they are able to sit on this important, I call this stage an important one, in fact, an enviable stage they find themselves on. Thank you very much, amazing teachers. And the students on this stage, the KNUST stage, thank you for representing your schools. I'm sure you have really burnt the midnight oil and see where you find yourselves, making yourselves proud, as well as making your various schools also proud. Are there supporters in the house? Hey, why? Where are they? I cannot feel your vibe. Okay, do you want to give yourselves a round of applause, supporters? Thank you. Thank you very much. And my name is Augustine Angelina Silverkin, Professor of Virology in the Department of Theoretical and Applied Biology. And I'm also a Senior Research Fellow at the Kumasi Center for Collaborative Research in Tropical Medicine. And I'm humbled to be your quiz moderator for this morning's competition. I deserve a round of applause. Right. So the Junior Science and Maths Quiz really is tailor-made for our learners who find themselves in the junior high schools, and the idea is to ensure science is extremely friendly, not just science, but mathematics, ICT, all the STEM-related programs or courses or subjects are friendly to them. And the idea is also to ensure the promotion of teamwork and, importantly, critical thinking, which is always very essential. And we feel it is important that these things are made available to our learners right from their early stages in life. Contestants, are you ready? Contestants, are you sure you are ready? Right. So competing in this contest, we have three schools, extremely good schools represented by brilliant young minds. And so we have St. Peter's Roman Catholic Junior High School, TEMA, on the stage. We also have Emmanuel Methodist Junior High School, and that is the spirit. I like these things. And then we also have ANCILLA Junior High School on the stage. So contestants, I need you to introduce yourselves. But before then, please leave your microphones on. St. Peter's, can you turn your microphone on? Is it on or is off? I'm not seeing well. Okay, let's see. So I need you to introduce yourselves by mentioning your names and your class. But I would want you to go further. This is the semi-final, so I don't know what your expectations are. And then you tell us your expectations. Is that okay with every one of us? So let's start with St. Peter's Roman Catholic Junior High School, TEMA, is proudly represented by
David Chikata, and I'm in my final year.
That's Form 3, right? Okay, your expectations?
Oh, we expect to come out successful and victorious.
Absolutely. And?
My name is Bright Atakpa, and I'm in Form 3. And then we pray God grants us success.
Amen. A round of applause for them. And Methodist, Emmanuel Methodist Junior High School is proudly represented by
Wachibichu's final year.
And your expectations?
Come out successful.
Excellent. And
Reginald John LC final year.
your expectations?
We are expecting a good contest.
Very good. A round of applause for Emmanuel Methodist. And ANCILLA Junior High School is also proudly represented by
Natu Ariel, final year, Basic 9. We expect to win by God's grace.
Absolutely. A round of applause for them. And
Asamoah Ifa final year, Form 3. And we are praying to God. We are hoping for the best, and we hope to learn a lot from this experience.
well said. Well done. Contestants, so you have buzzers in front of you, and you would need to use these buzzers to draw my attention to your schools or to yourselves. So let's do a short buzzer check. Can we hear the sound from the buzzer for St. Peter's? Good. Emmanuel Methodist. Very good. ANCILLA. Good. ANCILLA again. Emmanuel Methodist. St. Peter's. Right. So that, very well. Please clap for them. So there will be 5 rounds in this contest. Round 1, the fundamentals. Round 2, fastest finger, fastest brain. Round 3, the science and technology challenge. Round 4, decoding the clues. And round 5, the Global Nobel Prize Awards. Contestants, I'll be reading out the instructions at the beginning of every round, and my expectation is for you to pay attention. I don't know what people are writing, but but they are already writing a lot of things on their papers, but that's fine. So we start with round one, the fundamentals. So here I'll be posing questions in the areas of biology, physics, chemistry, mathematics, and ICT. If a school answers a question correctly, 3 points will be awarded. If it is incorrectly answered, it becomes available as a bonus to the 2 other schools to compete for. The score for a bonus question is a point or 1 point. And schools, you would have 15 seconds to answer questions that do not require calculations, and 50 seconds to answer questions that require calculations. And the schools, so contestants, you would have a maximum of only two attempts to answer your main question and 1 attempt to answer a bonus question. And like I said, bonus questions are open to the 2 other schools to compete for. But you do this competition by ringing the buzzer. If you fail to ring the buzzer before you answer a question, a bonus question, then I will nullify that particular answer. Imagine if the answer is correct. So it means that under such a circumstance, no points will be scored. No points will be scored. I wish you all the best. So we move. We start with the first question. And there's a preamble to all the schools. There's a preamble to all the schools. Which specialized cells perform this function, and which tissue are they part of? I'll take it again. Typically, I don't read questions again. Which specialized cells can perform this function, and which tissue are they part of? St. Peter's. A plant is growing in dry soil. To increase water absorption, the plant produces more cells with long, thin extensions that can increase surface area.
The cell is the root hair cell, and the tissue is the root.
I will not give that. Yes, Emmanuel, Methodist.
The cell is the apical meristem, and the tissue is the root tissue.
Unfortunately, that is also not correct. I'll hold on with the answer. Emmanuel Methodist, your main question. A plant needs to transport water from its roots to its leaves during a hot day. It relies on long, tube-like disease cells arranged end to end.
The specialized cell is xylem, and the tissue is vascular tissue.
I will not give it to them. But you have another chance. You still
The
have.
specialized cell is the stem cell, and the tissue is the vascular tissue.
That is not correct. Who rang first? St. Peter's. Yes, St. Peter's. Oh, unfortunately, time out. Again, I'll hold on. ANCILLA. A plant closes its leaf pores during hot afternoons to prevent water loss. This depends on special curved cells that control the pores.
The cell is the guard cell, and the tissue is the guard tissue.
No, you have another opportunity.
The cell is the guard cell, and the tissue is the mesophyll tissue.
That is not correct. Emmanuel, Methodist.
The cell is the gut cell, and the tissue is the leaf tissue.
That is not correct. Oh, my contestants. Right, so St. Peter's, yours had to do with absorption of water. And we know it's the root hair cells. But importantly, they are part of the epidermal tissue. Epidermal tissue. And then Emmanuel Methodist. It has to do with the transport of water. And typically, the cells are dead cells. And we know it's the xylem vessels. But the tissue is the xylem tissue. The xylem tissue. Then, ANCILLA. You got your guard cells well. But then the tissue they are part of, it is the epidermal tissue. All right, epidermal tissue. So I hope we are all learning something. The next question, I'll give you 15 seconds. There's a preamble. Name 3 elements or ions that are isoelectronic with the following ions and elements. Emmanuel Methodist. Neon.
Sodium ion.
Correct. 3 points. ANCILLA. Argon.
Chlorine ion.
You have another opportunity.
Potassium ion.
3 points. So you know why I did not accept the chlorine? It has to be chloride, all right? St. Peter's, helium.
Hydride.
Hydride, 3 points. Well done. The next set of questions, 15 seconds. And again, there's a preamble. Please listen to this attentively. Samantha receives an email from her bank asking her to click a link and enter her account details. The email looks almost identical to the real bank's website. Do you want me to take it again? All right. Samantha receives an email from her bank asking her to click a link and enter her account details. The email looks almost identical to the real bank's website. ANCILLA. What type of cyber threat is this? And explain briefly.
The cyber threat is phishing, and phishing is the situation of trying to gain valuable information from an individual over the internet by posing as a...
3 points. 3 points. 3 points. St. Peter's. State 2 ways on how Samantha should respond to this email.
She should go to the bank and ensure that it came from the bank itself. And then she should ensure that the sender is verified.
3 points. Well done. Well done. Emmanuel Methodist. Just give me 2 steps that the bank can use to prevent customers from falling for such attacks.
Education. And the second way.
John, it's so difficult to hear you. You don't touch the microphone, of course. Go on.
Education and also verifying foods so that users can help to differentiate between the authentic messages and other fake messages.
3 points. 3 points. 3 points. 3 points. The next question. Question 4. Again, there's a preamble. The marks scored by 6 students in a test are 9, 11, 13, 15, 10, 6. The teacher decided that the last two students' marks, which is 10 and 6, should be counted twice due to extra assignments. St. Peter's, find the weighted mean of the marks. Come again?
10.
That is correct for 3 points. Well done. Emmanuel Methodist, find the weighted variance of the marks. Unfortunately, you missed out on it. St. Peter's.
Root 10.
That is not correct. We still have some time. Okay, so I'll hold on with the answer. ANCILLA, find the weighted standard deviation of the marks.
Nine.
That is not correct. You still have some time. Emmanuel Methodist.
It is 72.25.
That is not correct. Okay, so they got the weighted mean correctly. The weighted variance, you know how to calculate variance. I won't go through it, as well as the standard deviation. So Emmanuel Methodist, the correct answer is 8.5. I'm sure you missed out on some calculations, additions or something. And then ANCILLA, the weighted standard deviation, 2.92. And I think one school calculated one, and then you should have used their answer to enable you calculate the rest. That's how come I held on to the answers. Question 5, I'll give you 50 seconds. Again, there's a preamble. A 24-volt battery is connected to a circuit as follows. A resistor with brown, black, orange is in series with a parallel combination of orange, black, brown, red, black, brown, I'm sure you got it. Okay. Emmanuel Methodist. Determine the value of each of the resistors.
The first one is 1,000. The second one is 30, and the third one is 20.
Do you want to come again?
Okay, so the first resistance is 10,000 ohm. The second
Emmanuel, it's very difficult to hear you. Don't touch the microphone, okay? Yes, go on and provide the answer.
The first resistance is 10,000 ohm. The second resistance is 300 ohm, and the third resistance is 200 ohm.
That is correct. 3 points. Emmanuel, you need to be audible and don't touch the microphone, okay? I think you should just position the microphone and stop turning it up and down. Emmanuel, John, okay? Just position it, and once you are ready with a response, just speak into it, and you have to be audible. It's very difficult to hear you. Is that okay? Right. ANCILLA. Find the total resistance.
$600 kilo ohms.
That is not correct, but you still have another opportunity. St. Peter's?
10,120 ohms.
Correct. 1 point. 1 point. Well done. St. Peter's. Find the current through parallel branch of the resistors.
It is approximately 0.002 amperes.
No, but check out on your calculation.
0.02 ampere.
That is correct. Emmanuel Methodist.
0.2 amperes.
That is also not correct. There's still some time. Oh, unfortunately, time is up. No, I was looking in your direction, and then I saw that the time was up. I'm also timing. Don't worry, we'll get it checked for you. I will check it for you. All right. So let's check your buzzers. Let's do a buzzer check, and then I'll provide the answer. Yeah, so it's working. So the correct answer is 2.5 milliamps. My eyes are very sharp. I'm always looking. All right? So be rest assured. You will never be denied of an opportunity. Is that all right? Do you want to check your buzzer again? Check it. Just press it. Is it working? Very well. So for the next set of questions, contestants, I'll be making statements, and I expect you to state whether the statements are true or false. ANCILLA, are you listening to the instructions? So the questions cannot be passed on as bonuses. Okay? ANCILLA, your main question. Electronegativity generally increases across a period from left to right.
True.
That is true. 3 points. St. Peter's. Atomic radius increases across a period from left to right.
False.
That is indeed a false statement. Well done. Emmanuel Methodist. Electron affinity becomes more negative across a period from left to right.
True.
Indeed, a true statement. St. Peter's. Electrons can move freely in a conductor even when it is isolated from the ground.
True.
Indeed, a true statement. Emmanuel Methodist. The force between 2 point charges decreases linearly with distance.
True.
Unfortunately, a false statement. But please clap for them. The last one, ANCILLA. The sparks seen during dry weather are caused by static charge accumulation in the air.
True.
Indeed, a true statement. And on that note, we have come to the end of round 1. We want to appreciate all our sponsors. Thank you very much, KNUST e-Learning, KNUST Institute of Distance Learning, Dex Technologies, Ghana Grid Company Limited, MTN Stakeholders Management, Nestle Ghana Limited, Diopta Eye Consult, Heli Manuel Cakes and Catering Services, and our media partner, Kesben TV and Radio. We say thank you very much. So the scores are in. And at the end of round 1, St. Peter's Roman Catholic Junior High School TEMA has 16 points. Please clap for them. Emmanuel Methodist Junior High School, 12 points. Please clap for them. ANCILLA Junior High School, 12 points. Please clap for them. Well done, contestants. So we move to round 2. Round 2 is the fastest brain, fastest finger. And here, one question will be read out, and contestants, you will compete to be the first to answer the question. Each question carries a score of 4 good points. And once you are ready to respond, you need to press your buzzer before you attempt to answer. Answering before pressing the buzzer will disqualify your school from answering that particular question. So once the buzzer has been pressed, please provide or produce your answer within 3 seconds. 3 seconds. The timers will be checking on the time. 3 seconds. Don't mention my name. Don't say madam. Don't repeat the question. Straight to the answer. And if a school gets the question wrong, the 2 remaining schools get to compete to answer. Each school will have a maximum of only 1 attempt. 1 attempt to answer the question. And here, in this round, a wrong answer will attract a penalty of 1 point. 1 point. And like I would always say, guard your marks with all your hearts. I wish you all the best. The first one. Let's do a buzzer check. Emmanuel Methodist, ANCILLA, St. Peter's, ANCILLA, Emmanuel Emmanuel Methodist, ANCILLA, St. Peter's, Emmanuel Methodist. Right, we move. Compounds formed by combining an alcohol and an acid is called St. Peter's.
Esther.
4 points. Well done. Well done. Well done. Next one. 2 blocks of masses 3 kilograms and 5 kilograms are connected on a frictional surface whose coefficient is 0.2. Force is 16 newtons on 2 kilogram block. Oh, time up. I actually ended the question. 0. It is 0. If you did your calculations well. 0. 0. The next one. Solve for x. Log subscript 2. Bracket open. X raised to the power 3. Bracket close. Equals 9. Emmanuel Methodist.
Okay, so x is equal to 8.
Correct. 4 points. Next one. The macromolecule whose sequence is determined by DNA and performs cellular functions is ANCILLA.
A gene.
-1. Emmanuel.
Chromosome.
-1. It's a protein. It's a protein. Macromolecule. Next one. The indicator that turns colorless in a ANCILLA.
Phenolphthalein.
4 points. Next one. Data type representing true or false. St. Peter's.
Boolean.
4 points. Next one. Last two. Now listen attentively. 2 particles. M1 equals 4 kilograms and M2 equals 6 kilograms. Move along a straight line. M1 has a velocity of 8 meters per second towards the right. M2 has a velocity of -2 meters per second towards the left. They undergo a perfectly Emmanuel Methodist
2 meters per second.
-1. Perfectly elastic collision. Find the final velocities of both particles. St. Peter's.
The velocity of the first one is 8 meters per second, and the second one is -2 meters per second.
-1. We still have some time. -1 plus 4. Angela,
2 meters per second.
-1. So the correct, so velocity 1 will be -4 meters per second. And then velocity 2, 6 meters per second. Towards the left, towards the right. The last question. Point S, bracket open, -1, 2.5, bracket closed, is transformed in the following steps. Scale by factor 0.5 with respect to the origin or to the origin. Rotate 90 degrees clockwise about the origin. Translate by vector 3 minus 1. Find the final coordinates of x, s, of s. Angela?
2.2. Negative 1.5.
-1, St. Peter's.
3.5 and 0.25.
-1. Emmanuel Methodist.
Negative 0.5, 1.25.
-1. So the correct answer is 4.25, 0.5. And on that -1 platform, we have come to the end of round 2. Remember, the quiz is organized by the KNUST, supported by the College of Science and the College of Engineering. We say thank you to all our sponsors for coming on board to support us in various ways. So this particular quiz is sponsored by KNUST e-learning, KNUST Institute of Distance Learning, Dex Technologies, Ghana Great Company Limited, MTN Stakeholders Management, Nestle Ghana Limited, Diopta Eye Consult, Helimanuel Cakes and Catering Services, and to our media partner, Kesben TV. We say thank you. At Kesben TV, we say Obia Bedidi. So let's check out on the scores. So within round 2, St. Peter's Roman Catholic Junior High School, they made 6 points. Please clap for them. Emmanuel Methodist, they made a point. Please clap for them. And then ANCILLA Junior High School made a point. Please clap for them. Now listen to this one, the total or the totals. So at the end of round 2, St. Peter's Roman Catholic Junior High School TEMA has 22 points. Please clap for them. Well done. Emmanuel Methodist Junior High School, 13 points. Please clap for them. Well done. ANCILLA Junior High School, 13 points. Please clap for them. So we move straight to round 3. Round 3 is the Science and Technology Challenge. And here, one question will be given to all schools. And the question in this round is such that the contestants will perform a task, after which an assessment will be made. The score for this round is 15 points. And contestants, I'll give you 15 minutes to complete the task. I don't know what people are reading, but at least look at me. We'll get into what is in front of you later on. So the round 3 is powered by Dex Science Set. Now let's go through the preamble. So I have provided you with a short fiber optic cable and a laser pointer. Your task is to investigate how light travels through the fiber and then draw a ray diagram to show how it occurs inside the cable. So the task, what you need to do is that you need to shine the laser into one end of the fiber optic cable and observe what happens to the light. Then you slightly bend the cable and shine the laser through it again. Then you make an observation. Then the third thing you need to do is to bend the cable more sharply and note down your observation as well. The last task will be for you to draw a ray diagram showing how the light inside the fiber travels through it. Then I have some related questions for you. But before we go to through the related questions, let me know, do you have your short fiber optic cable and your laser pointer? St. Peter's, yes or no?
Yes.
Emmanuel Methodist, yes or no? Is it a yes? Good. ANCILLA, is it a yes? Great. So your questions, related questions, is to write down the colors observed in tags 1, 2, and 3. And then indicates the phenomenon that allows the light from the laser to travel through the curved fiber optic cable. And importantly, I'll need you to state 2 real-world applications of fiber optic cables. And since you have everything, contestants, you may start work now. All the best. Okay, we are back. And such an interesting hands-on experiment we asked or we tasked our contestants to execute, all thanks to DEX Technologies. And indeed, at DEX Technologies, practical science is indeed practical. Very simple activity, very simple activity. So we ask that you actually provide us with the drawings of a ray diagram, because whatever you did had to do with rays going or passing through a certain tube. But this time, not just any kind of rays, but optic fibers in this case, right? Rays going through the fiber. So we gave you a laser light, so the light had to go through the fiber. So simple. Once you provided me with a nice drawing, 5 points straight away. I was interested in the direction of the drawing or the race. So I'm sure you can already start to mark yourselves. The direction is important because we actually asked you to put the laser at one side of the tube and then of the fiber so that it goes through. So the direction is very important. And then we also asked you to write down your observations. Obviously for task 1, the bright light, definitely you saw it as bright spot, and I actually came round. I saw that the light was there, extremely bright from one end of the fiber and then exited at the other end of the fiber. So if you are able to provide me with these 2 points for task 1. Task 2, we asked you to bend the fiber slightly, to bend it slightly. And of course, if you did your bending slightly, the cable slightly, if you bended the cable slightly, the light became dim, or it was dimmer than before. Then again, we also asked that this time you really bend it sharply, so it would have decreased the amount of light. So again, I'm sure you are marking yourselves. So task 1, 2 points, task 2, 2 points, task 3. So a gradual decrease in the intensity of the light. Then importantly, we also asked you to provide us with the phenomenon. And the people wrote interesting things. We'll come to that. But this had to do with total internal reflection. Total internal reflection. And I'm sure you remember total internal reflection in physics, right? Do you want me to go over total internal reflection? Okay, they are like this. Then application or applications, only 2, a lot of things. So even in the hospitals, they can use it to perform surgeries. We see a lot of fiber optics all over. So our TV stations, they use that. Internet providers, they use that. Telecommunication industry, they use that. Like I said, in the hospital, medical imaging. Now they don't really need to open you up. They can use some of these things to perform surgeries. Then sometimes Christmas is actually around the corner. You realize that the lights are bent. They are bent. Past tense of bent. Yes, they have been bent. It is because of this particular phenomenon. So if you were able to list all these things out, then 2 points, making a total of 15 points. So I'll go by the way they submitted their sheets. This is St. Peter's. They drew something very nice. They actually labeled it nicely, but it's just a fiber optic cable without anything. I don't see any direction, but then at the end there's light, there's visible light. And they drew it so very well, but this doesn't show me any total internal reflection, but a lot of effort. So I'll give them 1 point for the drawing. And then the related questions, they have written here, and they've cancelled a lot. I don't know why. The light cancelled laser traveled through the fiber optic cable but was only visible at the other end of the fiber optic cable. 2 points. Then they've cancelled a lot of things. Task 3. The light still appeared due to the phenomenon of diffraction. That is not correct. But task 2. The laser appeared at the other end, but it was dimmer as compared to the brightness in task 1, which is very true. So 2 points, making 4. Phenomenon, they've written diffraction of light. That is unfortunately not correct. But then the real world applications, very well written, connect to the internet and then use in data transmission. 1 point each, making 2. So that means that for St. Peter's, they have a total of 7 out of 15. Well done. Please clap for them. ANCILLA, they've drawn something nice here. No label, no direction, but I see that they put in a lot of effort. I actually see that it's the light moving, but I needed to see the direction, very important, of the light. So I'll give you 2 points for the drawing, 2 out of 5. The related question. So first one, task, well done. Second task, well done. Third task. In task 3, the light can be seen through the fiber optic cable, brighter than in the previous task. That wasn't true. So unfortunately, you don't get anything. Then the phenomenon. They have written refraction of light, and that is not true. But then again, real-world applications of fiber optic cables, very well written, networking cables, lighting systems. So 1 each. That makes them, it means for ANCILLA, they have 8 out of 15. Please clap for them. Well done. Emmanuel Methodist. Well done. Congratulations. I will always say congratulations. So please listen to what they have provided us with. But thank you for clapping for them. So they have the diagram. The directions are there. Directions, so the entrance as well as the exit. Well done. 5. Straight away. 5 out of 5 for you. And then, task 1, well executed. 2, well executed. 3, they had issues. So there's really nothing here. Light rays was seen at the point where the cable was bent sharply. There's really, then the phenomenon, well done. Total internal reflection of light. Well done. But listen to the real world applications of fiber optic cables. Communication over long distances, well, then they wrote telescopes. And that is not true. So you get only 1 for this one. So in total, Emmanuel Methodist, they have 12 out of 15. Well done. Well done. Very, very well done. So now let's check out on the totals for our marks. And so at the end of round 3, St. Peter's RC Junior High School TEMA, they have 29 points. Please clap for them. Emmanuel Methodist Junior High School, 25 points. Please clap for them. And ANCILLA Junior High School, 21 points. A round of applause for them. Well done. Well done. So we move straight to round 4. Round 4. So round 4 is decoding the clues round, and here the questions will be read out as a series of clues. Contestants, if you are able to answer the question correctly on the first clue, 6 points. 6 points will be awarded. And if answered correctly on the second clue, 5. 5 points. Third clue, 4. Then fourth clue or any other clue, 3 points. But you need to press your buzzer before you provide the answer. And if you fail to press your buzzer, but you go ahead, then unfortunately, I will nullify your answer in this case. Let's do a buzzer check. St. Peter's, Emmanuel Methodist, ANCILLA, Emmanuel Methodist, St. Peter's, Emmanuel Methodist, St. Peter's, ANCILLA. Right, all the best. The first one. I provide mechanical advantage by relating two radii and transforming torque through a rigid connection. When effort is applied at the larger radius, Emmanuel Methodist.
Wheel and axle.
5 points. Next one. Next one. At the microscopic level, I occur by direct collisions and energy exchange between neighboring particles or by free carriers hopping between atoms. I'm fastest in tightly bound Emmanuel Methodist. St. Peter's.
Active transport.
And much slower in gases because particles are closer together in solids. Metals excel at me because ANCILLA.
Conduction.
Conduction, 4 points. The last but one. Last but one. Today my clues are long. Okay. My classical name comes from a word in Latin which hints at how people originally prepared me. Chemists might casually file me under the broad headings of salts, for I am formed when acids and bases, St. Peter's,
Salt.
meet and settle into an ionic partnership. Yet, that label hides much of what I do. In practice, I behave like a blend partly made from organic chains that love oily grim and partly carrying organic groups that prefer water. So I sit at the border between greasy and watery worlds. ANCILLA.
Crystal.
Though I do dissolve in water to perform my work, I am not endlessly soluble. Instead, I disperse enough to form films and bubbles that trap dirt and let it drift away. I am strangely choosy about the water I meet. In hard water, my helpful action is hampered. But when I meet soft water, I foam as if I were celebrating producing a rich lather that makes washing easy. The last one. From gentle hand washes to industrial scoring, my twin nature hydrophobic tails that sees oils and hydrophilic heads that carry them into the water makes me the everyday cleaner. Who am I? Emmanuel Methodist.
washing soda or sodium carbonate.
That is not correct. Supporters, anyone to help us? Oh, really? Okay. It is soap. Soap. I'm sure we all used soap this morning to bath. And we have washed our hands if we have visited the restroom. Soap. Okay, the last one. I told you that today the clues are very long and winding, which is good because it's the semi-finals. The last one. In everyday life, I appear when people portion food or convert totals into per person amounts, quietly answering questions about equal shares and fair distribution. Emmanuel Methodist.
Proportion.
When one number multiplied by another number gives a product, applying me to the product with the second number often returns you to the first. You will recognize my result as quotient or fraction. ANCILLA. All fractions, St. Peter's.
Division.
That is correct. On the fourth. And on that note, we have come to the end of round 4. Congratulations to all the competing schools. Please clap for our contestants. Well done. So let's look at the score. So within round 4, St. Peter's, they made 3 points. Emmanuel Methodist, 4 points. ANCILLA, 4 points. Now the totals. So at the end of round 4, St. Peter's Roman Catholic Junior High School, TEMA, 32 points. Please clap for them. Emmanuel Methodist Junior High School, 30 points. Please clap for them. ANCILLA Junior High School, 25 points. Please clap for them. So we move to round 5, but we have a number of substitutions. So for Emmanuel Methodist, Beatrice Boache is leaving us, and Adeline Kwache is coming in. Well done, Beatrice. Well done. You have proudly represented your school, and you have made yourself and your school proud. Congratulations. Adeline. Is it Adeline or Adeline? Adeline, you are welcome. And then there's another one from ANCILLA. Justine. So who is going out? Ariel Natu is going out for Justine Ado to come in. And then Efwa Samoa is coming in for Triumph Yidana to come in. Well done. Efwa and Justine, well done. You're welcome, ladies and gentlemen. So I'll let you introduce yourselves by mentioning your name and your class. Emmanuel Methodist.
Adeline Ejekaj, final year.
All right, please clap for them. Angela,
Triumphidana, final.
can you pronounce your name again?
Triumphidana, final.
Right. And
Justin Ado, final year.
Justin Ado, final year, meaning Form 3. It means Form 3, right? Final year. So we move to round 5. Round 5 is the Global Nobel Prize Awards. And here there will be 3 sets of questions. Each question has a main question and 2 sub-questions. Schools will compete to be the first to ring their buzzer. The first school to ring its buzzer will be allowed to answer the first question. If the school answers a question correctly, then they will have the sole right to answer subsequent question. The main question will be passed on for 4 marks if it is incorrectly answered by the school that rings the buzzer first. Sub-questions in a set will be passed on as bonus if it is incorrectly answered. And bonus questions will always be competed for by pressing your buzzers. 3 points. 3 points will be awarded for answering the main question correctly, of course, and 1 point for each of the sub-questions, making a total of 5 good points. And when any of the competing schools is unable to answer the question will come to an end. Let's check our buzzers. Emmanuel Methodist. ANCILLA. St. Peter's. St. Peter's, ANCILLA, Emmanuel Methodist. Right, the first one. Wolfgang Pauli discovered the 2 electrons in an atom. So I'll start again. Wolfgang Pauli discovered that 2 electrons in an atom cannot have the same. Emmanuel Methodist.
Exclusion principle.
Correct. Emmanuel Methodist. Emmanuel Methodist. Why does this principle prevent all electrons from collapsing into the nucleus?
Okay, so this is so because when the electrons collide into the nucleus, it will bind with the.
No, that is not correct. But time was up, or it was their time. It was their time. St. Peter's.
Wolfgang Pauli's exclusion principle is important because it prevents 2 electrons from having the same quantum number. Or else, if they have the same quantum number, the energy will be too much for them and they will spiral into the nucleus.
I'll give it to him. 1 point. 1 point. 1 point. So they occupy different energy levels. 1 point. Well done. So to you, how does this principle explain why atoms have different sizes?
This principle explains why atoms have different sizes because if they have the same quantum numbers, the electron size will be the same. But it prevents 2 electrons from having the same quantum number, thereby leading to the differences in the sizes of the electron.
No, Emmanuel Methodist.
Okay, so this concept.
Oh, so
helps.
Emmanuel, no, you have already been ruled out because you actually answered the first question and then you were unable to answer the second question. So it has to be either ANCILLA or we end that question. So the principle explains why atoms have different sizes because if we have more electrons, then they will require more orbitals and they will definitely require more energy levels. And of course, if they do this, then they will push electrons further out, making larger atoms move out of that environment. So that's how come I was not able to give it to you. Next question. There are some interesting names here, so I'll take my time and pronounce them. Otohan and Les Mitna unofficially discovered transuranium elements beyond uranium through nuclear reactions. What is a transuranium? St. Peter's.
A transuranium element is a type of element whose one atomic number exceeds uranium 2. Its extraction is more difficult than uranium, and also it means uranium and some other elements are the main reactive metals, but some of them have later been discovered to be reactive, and those elements are the transuranium elements.
He has given me a lot of answers. ANCILLA.
A transuranium element is an element that is derived from uranium by bombarding it with electrons.
He said by doing what?
By bombarding it with electrons.
I will not give that. Emmanuel, Methodist.
A transuranium element is an element between that has an atomic number between 92 and 130.
3 points. 3 points. 3 points. 3 points. Okay, so Emmanuel Methodist. Why are transuranium elements radioactive and unstable?
Okay, so transuranium elements are unstable and they are also radioactive. This is so because they don't have an exact atomic, and hence they undergo nuclear fission in order to be stable.
In Peters.
They are radioactive because they have unstable nucleus or nuclei, and they disintegrate to release, and they undergo spontaneous decay, and they release alpha, beta, and gamma
ANCILLA.
particles.
This is because they are bombarded with particles from radioactive decay of uranium, such as alpha particles, beta particles, and gamma particles. And this creates an imbalance in their electronic configuration, making the amount
I
of...
am not able to give it to any of you. They have too many protons. They have, yes, and you know, you were actually giving me my words. You were giving me my words. They are radioactive. I wanted to know why they are radioactive and unstable, because they have a lot of protons. And if they have a lot of protons, it means that the nuclear force will not be able to hold all the protons together. So definitely they will break apart. And that is how come radioactive. So they will typically undergo radioactive decay, isn't it? But the important thing is that they have too many protons. I realize you were all giving me words, radioactive. Yesterday I mentioned keywords, right? So unfortunately, that will come to the end of this particular question. The last one. Claude Deduve and Palade discovered that ultrastructure of cells using electron microscopy. How did electron microscopy reveal St. Peter's?
Electron microscopy helped because it helped to view very minute particles clearly by the bombarding of electrons. So very minute particles are viewed clearly.
That is not correct. Emmanuel Methodist.
Okay. Okay, so they have helped to build fragments of tiny particles such as organelles, which cannot be seen by the um, light microscope.
Ancilla, that is not correct. Ancilla.
So using the electron microscope, they're able to magnify the 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 cells to get a highly focused and precision glimpse at the structures of it.
That is not correct. I'm surprised because they didn't even wait for me to finish the question. They decided to set their own questions or their own question. So you should have waited. And the question was, electron microscopy reveals structures invisible to light microscopes. And the correct answer is that they have extremely short wavelengths. I don't know where you got your question from. So unfortunately, that's the end of this particular question. And we go for a short commercial break. We go for a short Okay, so as always, there is one protest, and this is from Emmanuel Methodist Junior High School. And the round is round 2, speed race, a physics question. Their complaint is that the question was incomplete. And the question was, 2 blocks of masses 3 kilograms and 5 kilograms are connected on a frictional surface whose coefficient is 0.2 for 16 newtons on 5 kilogram block. The answer was 0. Indeed, the question was incomplete. And so their verdict, they have provided their own verdict. They should have waited for me to provide my verdict. So I will ignore their verdict. But my verdict is that I will provide another question. It was the fastest finger, fastest race. So I will provide another question and then we'll see how it goes. So because it is fastest finger, fastest brain, can we hear the sound from the buzzer for St. Peter's? Emmanuel Methodist, Ancilla. Right. So the question goes, 2 blocks of masses 3 kilograms and 5 kilograms are connected on a frictional surface whose coefficient is 0.2, force is 16 newtons, or a force of 16 newtons is exerted on the 3 kilogram mass. So I'll read it again. 2 blocks of masses 3 kilograms and 5 kilograms are connected on a frictional surface whose coefficient is 0.2, force 16 newtons is exerted on the 3 kilogram mass. Find the acceleration of the system. All right. So our consultants have submitted another question. And let's check our bases. Emmanuel Methodist, ANCILLA, St. Peter's, St. Peter's, ANCILLA, Emmanuel Methodist. All right. So there's another question from our consultant. Before I read that particular question out, I think it is just fair that the contestants who represented the respective schools need to join us on the stage, and then the question will be provided. So if Adeline can leave us, and Triumph and Justine can leave us. So Efua Samwa and Ariel Natu. Okay, so ANCILLA, test your buzzers or your buzzer. Emmanuel Methodist, St. Peter's. All right. 4 kilograms and 2 kilograms are connected by a light string and placed on a horizontal surface. The coefficient of friction between each block and the surface is mu equals 0.1. A horizontal force of 60 newtons is applied to the 2 kilograms block pulling the system. Take G to be 10 squared. Find the acceleration of the system. Okay, time is up. Time is up. The correct answer is 1. Come to the end. The contest. First semifinals for the 2025 Junior Science and Maths Quiz. Now I'll present the results in ascending order. ANCILLA Junior High School, they had 26 points. Please clap for them. Junior High School, TEMA, 34 points. Please clap for them. And Emmanuel Methodist Junior High School, 37 points. Please clap for them. ANCILLA on this same stage or 20, it's not 2027, 2026 Junior Science and Maths Quiz. Well done. I am proud of you. You should be proud of is also super proud of you. Congratulations and well done. Methodist, Emmanuel Methodist, not Methodist Emmanuel. Emmanuel Methodist Junior High School. Congratulations for making it to the finals. It will be a pleasure to host you on this same stage. Go and prepare very well, and we'll see you on Saturday. There's another contest coming up, and this one, it is going to be fireworks. It's going to be between Woodbridge International School, MA Crick JHS, and Best Brain Academy. And I'm sure we will all stay put, glued to our sets, and watch this exciting competition. Remember, this year's competition has been proudly sponsored by the KNUST e-Learning, KNUST Institute of Distance Learning, Dex Technologies, Ghana Great Company Limited, MTN Stakeholders Management, Nestle Ghana Limited, Diopta Eye Consult, vsEMMANUEL Cakes and Catering Services, and to our media partners, Kesben TV. We say thank you very much. Have a good afternoon, and we'll see you later in the day.